7. Let's talk about symmetry and even and odd functions. So here's a picture of a graph that has x-axis symmetry. Something you should notice about this graph is that it is not a function. It also doesn't have x-axis symmetry the way they have it drawn. So let's just fix that. We're going to pretend like their x-axis is here, because x-axis symmetry should look like a graph that you could fold across the x-axis. So what makes it not a function is because it fails the vertical line test. Let's see about this one. This graph does have y-axis symmetry. If I folded this graph across the y-axis, it would have a point here, xy, and a matching point here that is negative xy. Let's look at this matching point over here. This point would be xy. Its matching point would be x negative y. All right, origin symmetry. Origin symmetry is also called 180-degree rotational symmetry. And with 180-degree rotational symmetry, what happens is that you can reflect across the x-axis and then the y-axis, and you get the same graph. Or if you hold the origin still and spin the whole graph upside down, the graph would look exactly the same. So the point that would be the same here would be x, y, and its matching point would be negative x, negative y. So to test for symmetry, what we're going to do is replace every x with the opposite of x. So if you look at this one, if I replace x with the opposite of x, I still get out y. Actually, I wanted to put this here. xy, negative xy. I shouldn't have chosen one down here. So if it's not too late, ignore those points. xy, negative xy. If I replace x with negative x, I get out the same y value. On origin symmetry, if I replace x with negative x, I get out the opposite y value. And then with x-axis symmetry, what I'm going to do is replace every y with the opposite of y, and the result will be the same as the original equation. So, what we want to do for symmetry, replace every x with the opposite of x, put that in parentheses. If the result is the same as the original equation, then the graph has y-axis symmetry. Then but if the result has all opposite signs, then the graph has origin symmetry. Then we're going to replace every y with the opposite of y to test for for x-axis symmetry. If we replace every y with the opposite of y and the result is the same as the original equation, then it has x-axis symmetry and it is not a function. So we're replacing every x with the opposite of x. Step 1. If the result is the same as the original equation, then it has y-axis symmetry. If the result has all signs opposite except for the y, then it has origin symmetry. Then we're going to replace every y with the opposite of y. If the result is the same as the original, then it has x-axis symmetry and is not a function. So let's get some practice in. Test for symmetry with respect to the x-axis, y-axis, and origin. So the x-axis test is replacing y with opposite y. The other two is replacing x with the opposite of x and then checking to see what the result is. So the y-axis and origin, we're going to replace x with opposite of x. So we'll do that first. Y equals x squared plus 4. So I'm replacing x with opposite of x in parentheses. And then I work through that. Negative x times negative x is positive x squared. So this is x squared plus 4. Now, comparing that to the original, it is exactly the same. So this graph is going to have y-axis symmetry. To test for x-axis symmetry, what I'm going to do is replace the y with the opposite of y. And if I end up with the same as the original, then it has x-axis symmetry. So I replace y with opposite of y. So opposite of y in parentheses is the same as negative y. And if I compare that with the original equation, is negative y equals x squared plus 4 the same as y equals x squared plus 4? It is not the same, so it does not have x-axis symmetry. Okay, let's look at B. So again, we're going to start with replacing every x with the opposite of x, because that's going to test for y-axis and origin symmetry. So testing B. I replace x with opposite of x. I forgot to. Opposite of x equals y squared minus 3. Opposite of x is negative x. So is negative x equal x squared minus 3? Is that exactly the same as the original? It's not the same as the original, so it does not have y-axis symmetry. Are all the signs exactly the opposite of the original? Well, this sign is exactly the opposite, but those are the same. So it's not exactly opposite, so it has no origin symmetry. Let's test for x-axis by replacing y with opposite of y. So I keep x the same. I replace y with opposite of y. Go ahead and square that. I get x equals y squared minus 3. Checking with the original, that is the same, so it does have x-axis symmetry. I guess I could box that first one. In case you can hear screaming in the background, that is musical rehearsal. They are choreographing out in the courtyard. Okay, letter C. X squared plus y squared equals 16. So I'll start with replacing x's with opposite x's. So the opposite of x squared plus y squared equals 16. Opposite of x times opposite of x is x squared. So I get x squared plus y squared, whoopsie, equals 16. So we have, is x squared plus y squared equals 16 the same as the original? Yes, it is. So it has y-axis symmetry. Now let's test for x-axis symmetry by replacing y with opposite y. So I'm going to have x squared plus opposite of y squared equals 16. So that is x squared plus y squared equals 16, which is exactly the same as I started with, so it has x-axis symmetry. Now I have a little note down at the bottom of the page here that says if a graph has two types of symmetry, it automatically has the third also. The equation that we just tested has y-axis and x-axis symmetry, which means it automatically has origin symmetry. So because it has these two, it also has, oh, what did they call that? They didn't call it origin symmetry. Yeah, they did, origin symmetry. In fact, we know what this graph looks like. X squared plus y squared equals 16 happens to be a circle with a center at 0, 0 and a radius of 4. So if you draw that graph, you can see that it has x-axis, y-axis, and origin symmetry. Moving on to letter D. Test for y-axis and origin symmetry. So replace x with opposite x. So 2 times opposite of x plus y equals 4. That is negative 2x plus y equals 4. Is this the exact same signs, like the exact same as the original equation? It is not. So this graph does not have y-axis symmetry. What about origin symmetry? Are all of the signs opposite? Nope, all of the signs are not opposite, so it does not have origin symmetry. Let's replace y with opposite y. So 2x plus opposite of y equals 4. So that would be 2x minus y equals 4. Is that the same as the original? No. So it does not have any x-axis symmetry. So this graph actually has no symmetry with respect to any of those axes, x, y, or origin symmetry. Okay, what about y equals x cubed? So we're going to replace x with opposite of x. So we get y equals opposite of x cubed, which is y equals negative x cubed. Okay, so does this have all opposite signs on the right side of the equation? Yes, it does. The signs are not all the same, the signs are all opposite. So this does not have y-axis symmetry, but it does have origin symmetry. Let's check for, oops, that was supposed to be orange. Let's check for x-axis symmetry. Replace y with opposite y. So opposite of y equals x cubed. That's negative y equals x cubed. Is that the same as the original? No. So it does not have x-axis symmetry. Okay. Let's look at even and odd. Even and odd functions. An even function has y-axis symmetry, and an odd function has origin symmetry. So for an even function, I'm going to substitute in the opposite of x, and I should get back the original equation. That makes it have y-axis symmetry, which makes it an even function. Odd functions have origin symmetry. So if I replace the x with the opposite of x, I should get all opposite signs on the right side, which tells me it has origin symmetry and it's an odd function. So even functions have y-axis symmetry. Odd functions have origin symmetry. So we're just going to use the same test that we just did for even and odd, or that we just did for y-axis and origin symmetry. So use the same test for even and odd as you did for y-axis and origin symmetry, which was to replace all of your x's with the opposite of x. And if it's the same as the original, then you're going to have an even function. If it is opposites of the original, you're going to have an odd function. Okay, so let's look at A. So I'm going to replace x with opposite of x. So I'll have 8 times opposite of x to the 4th minus 3 times opposite of x squared plus 1, which gives me 8x to the 4th, because an even number of negatives comes out positive. And then this will be negative 3 times x squared, so minus 3x squared, and then plus 1. So notice that that is the exact same as the original, so this is going to be an even function. Letter B. F of opposite of x equals, I'm going to put 6 and then opposite of x cubed minus 9 opposite of x. Negative x times negative x times negative x gives me negative x times 6 is negative 6x cubed. Negative 9 times negative x is positive 9x. Looking at my original, I went from positive 6x cubed negative 9x to negative 6x cubed positive 9x. These are all opposite signs. So this is going to be an odd function. Looking at C, f of opposite of x would be 3 times negative x squared plus 5 times negative x. Negative x times negative x is positive, so that is 3x squared. 5 times negative x is negative 5x. So the 3x squared is the same as the original, but the 5x is the opposite of the original. And because it's not all the same and not all opposite, this one is neither even nor odd. So there is a general guideline that you can follow. You still have to prove it by showing work like I just did, but if a function contains only even exponents, including constants that have an exponent of 0, then it is an even function. If a function has only odd exponents and no constants, then it's an odd function. But if a function contains both even and odd exponents, then it's considered neither. But please remember that you need to practice showing your work, because on the test, if all you give me is an answer that it is even, odd, or neither, you are not going to get any credit for that without proving it by showing the work like we just did here.